with us today, and I'll hand it off to you, Steve.
All right. Thank you, Bren. Appreciate you all joining this morning. And so we've got about an hour, so I'll dive into things here. We're going to talk about prescriptive compliance with RBES and get into some of the points options that exist in the prescriptive compliance option, as that's an expansion, significant expansion of points options going into this updated code for July 1st. So what we're sharing today is copyrighted material from the ICC. Vermont RBES has been around here for a good 20 plus years at this point. It is updated on a 3-year cycle, and that brings us to where we are at here now with the updated RBES coming into play for July 1st. It would have typically gone into play last year, but there was some other conversation and debate that occurred last year to review the update content and push the implementation date back until July 1st of this year. But to find the code information, easiest way to get there, if not going directly to the International Code Council in the first place, but also the comprehensive source of all of the code documents is at the Public Service Department's website. So if you toggle through to the efficiency tab on the left-hand side of the welcome screen, that'll bring you to both the RBES and the CBES content. And if you click into there, this brings you to all of the versions of the RBES, from the original, the OG, the first code up through the 2020. And you can also, through this link, find the updated code content, which currently right now, there are 2 versions of it available as the edited document from the review process. The final published documents are not yet up on the ICC site. They will be hopefully sometime in the near future, but certainly before July 1st. And the code handbook is being updated as well. So that'll be available for July 1st as well. But this is the link on the department site that brings you to the ICC and to the full content of the code. And that is worth distinguishing here, the difference between the ICC published code document and then the Energy Code Handbook. These are 2 different things. The ICC published document is the actual statute, the regulatory statute, that is the law, quote unquote, of the code. So that ICC document contains all of the actionable language to comply with the code. And the handbook is basically a summary guide to help construction professionals apply the code. So the handbook is a reference document, but it is not the full code. So I would suggest navigating your way to the ICC site and accessing the code there. The trainings that I do are specific to the ICC published content that rather than the handbook. Efficiency Vermont's role in this, we are not the code enforcement entity here in the state. There is no code enforcement entity. So we are here to serve basically a supporting role. Bryn does an amazing job of putting me and others out there and content out there to support you all and provide as much information as we possibly can on the code. And we also maintain and run the Energy Code Assistance Center, where you can call this number here on the screen. Great, I didn't pause the prompt, so I apologize. The slide's moving on their own here. You can contact Efficiency Vermont at the toll-free number there, and we can assist you with any code questions that you have as you're working through projects. If you have deeper questions or policy-related questions, or the why is the code, saying that we have to do this, you can always reach out to the Department of Public Service as well, as they are the state agency that is kind of the overseer of the code here in Vermont, both residential and commercial. So what's in store for the updated 2024 code? As I said, the update process is typically on a 3-year cycle. It has shifted off of that routine over the years for a variety of reasons. But what the Vermont Residential Building Energy Standard is Vermont's version of the International Energy Conservation Code. So the ICC publishes model codes, which states, municipalities, jurisdictions can adopt as the basic framework and structure for construction standards. And then that model code is modified based on the climate zone for the energy code specifically, and then also state and local policies and or regulations. So that is how the code update process works. It was, again, that process occurred mainly in 2022. The final version of the updated code was approved by the Legislative Rulemaking Committee last summer. So the language is finalized and adopted, though, as I said, there was a delay in implementation to allow for a study committee that met last summer and into the fall to kind of review the outcome of the code update and future direction of where code updates and the code itself may be heading. So more attention being paid on this and more conversations to come, but we do have this code coming into effect as of July 1st. So buildings that must comply, we have both the residential and the commercial energy code. So the residential code is specific to essentially new construction, single family, 1 or 2 family dwellings. It does apply to multifamily as well. And the multifamily requirement comes into play for residential or mixed use buildings, 3 or more stories less in height. Taller than that, it starts to get into the territory of CBs. So there are also situations in mixed use where you may have a commercial or retail space on the ground level and residential units above. That's a scenario where both codes would be coming into play on that project. Tiny houses are now distinguished as a standalone category in the updated code that have their own building envelope specifications, different than what the standard new construction would require. So that's a new call out in the code for this iteration. Additions are basically treated as new construction, so need to meet the same standards of construction as a new house from the ground up would. And renovations, alterations, existing homes are still, there are still requirements within the code for those types of projects. And they are treated a little bit differently and are listed in Chapter 5 of the code. There are exemptions: unconditioned buildings, garages, outbuildings, sheds, etc. Do not need to meet the standard of the code. Seasonal buildings or camps, mobile homes have their own standards, yurts, and owner-built homes. So you have the technical compliance required for the code, which we'll talk about here today, which is kind of the building envelope, building mechanical systems, ventilation, standards of practice and installation of these materials and systems. And then you have the certification side of this. How are you showing compliance? And this is the code certificate piece of the equation. So you have the technical compliance with the code, and then you have to show how you complied with the code on this code certificate. And what we're going to talk about today, if you look at the code certificate in detail, the top of the certificate is basic details about the project, what type of project it is, the description, basic built conditions, square footage, bedrooms, etc., foundation type. And then the section below this are the 3 categories of compliance options with the code. The biggest of these 3 is the packages plus points, which is what we're going to cover today. And then the other 2 options are res check and HERS. And in res check and HERS, you're basically just putting in the UA or the HERS number result from the energy modeling that was done in those 2 compliance options. But packages plus points is what's considered a prescriptive compliance method, where you're choosing a standard set of specifications to meet, and then based on the square footage of the house, you have to upgrade certain components to earn points. And this is what these individual boxes are identifying here, which points options were chosen to show compliance. This is the 2020 code certificate, and as I said, the points options have expanded significantly for the updated code. So I don't know what the code certificate is going to look like. That has not been made available yet, but there's a lot more options than what's on this currently in the 2020 code certificate. So there'll be some iteration of this to be completed if you're using prescriptive compliance as your option moving forward. Below that on the code certificate are details of the construction of the building, these sections here need to be completed no matter which compliance option chosen. So you're putting in your R values of building assemblies here. Your mandatory required blower door testing results are going to be entered here in this section. Mandatory mechanical ventilation required for new construction, that information is going to be entered here. Balanced heat recovery ventilation is going to be mandatory as of July 1st now. You cannot use exhaust only anymore. We're not going to get to that in detail today, but that's a requirement. Mechanical system basis of design and specification of equipment is entered in this section, etc. So this needs to be completed no matter which compliance option you've chosen to use to comply with the RBES. Now, the way that the code is written and laid out and published is essentially as a design document. So all of the codes published by the ICC are arranged sequentially in that way. So you can think about, using the code as a resource tool to follow it chapter by chapter through the design and iteration process of design. And that's really the intent for how this is all should be put into practice. I mean, using the code as a guidance pathway to get you to the outcome of having a fully code compliant and durable, a safe and efficient building in the end is how this is meant to work. So I do not recommend kind of poking around in different chapters trying to find different aspects that relate to what you're trying to answer a question on currently at the moment, but to use the document in this pathway of iteration and design. So the general requirements section kind of covers the standards of basis of design for things like the ventilation system, sizing of the ventilation, sizing of the heating and cooling loads, conditions to use for those parameters for designing the heating and cooling loads and the equipment sizing, installation standards for installation. The bulk of the content in the code is in chapter 4, which lays out all of the 3 compliance options and then the specifics about how to put the building assemblies and components together to be compliant. And then, as I mentioned a moment ago, existing buildings are referenced in chapter 5. So what we'll focus on here today is the content that's in chapter 4. Specifically, these sections here are sections R402 through R408. These define your compliance options for the code. So again, as I said, we have the prescriptive package plus points, which is what we're talking about today. This is available to comply with both base and stretch code. Then the other 2 options to show compliance are both energy modeling approaches. One is an energy modeling tool that's available from the Department of Energy that the builder, the engineer, the architect, whomever it is that's certifying the building as compliant can use to model the performance of the building envelope, the building shell. It does not take into account the efficiency of any mechanical systems or renewables or air leakage successes in the building. It's strictly just the building envelope. And then the third option here being working with a third party, a HERS rater, to do the compliance and the energy modeling for you. If you're required to meet stretch code, you cannot use ResCheck as a compliance option. You either have to comply prescriptively or work with a HERS rater to show compliance for stretch code. So this prescriptive packages plus points approach has always been available as kind of the simple pathway to show compliance. It's simple in the fact that it dictates what your R values and U values need to be for different building components. But that's just the specified R value or U value for those components. There's a lot more involved in getting those pieces put together as a system and or an assembly. So there's more to this section of the code and how to get to the outcome rather than just the specified R values. So it does take more coordination with subs because you're not, there's different trades that are going to be involved in hitting some of the marks here that are required in the prescriptive compliance outcome and in any outcome really for that matter. But it doesn't require any modeling. You're just meeting prescriptive values as your basis of standard for compliance. Changes for the 2024 code are that currently in the 2020 RBs, there are two tables with packages available for both base code and stretch code. The base code, there are 5 package options to choose from. Stretch code, there are 3. Those packages and that table have been combined into a single table for the 2024 RBs, and there'll be 2 packages available to choose from. And then you need to earn points, as I mentioned, based on the square footage of the house. So again, this is what's in the 2020 RBs right now, 5 packages to choose from. Log homes have their own ICC standard. So these other packages are essentially stick-built construction. And then this is the points table from the 2020 RBs. So depending if it's an addition, or a multifamily building, or just general new construction square footage requirements and categories. These are the points options for base code that are in the 2020 RBs. This is what the prescriptive table looks like now. We have combined single package essentially, because again, that log home package does still exist in the table, but the log home standard is different, and it's a separate standard for construction if you're doing log construction. So what you'll see here are some significant changes. You'll notice would be that a flat ceiling, flat attic, rather than from the common package chosen most of the time for cavity only insulation in the current code, requires R60 for an attic flat. The prescriptive value for a flat attic in the updated code is R49. Sloped and closed ceilings are going from R49 in the 2020 RBs to R44. Above grade walls is quite a significant change here. The intent originally with the update to the code was to require continuous insulation for above grade walls. There's a lot of debate on this topic in particular during the update process and last summer. So where this is kind of sugared out is that the intent is to try to build continuous insulation walls, and here's some examples, quote unquote, that are offered in the table. But cavity only insulation walls are still going to be allowed in the updated code. And there's still some debate for how that's going to play out, and it sounds like there's probably going to be an additional points requirement necessary if you choose to do cavity only insulation. So the code is still iterating towards continuous insulation above grade wall assemblies, but that being said, there will still be an option to do cavity only moving forward here as of July 1st. Some other changes that are significant from the 2020 prescriptive values are slab insulation values are increasing to R20. So slabs on grade and or heated slabs are now going to need to meet R20 rather than R15. Window U values are at 0.30. There was initial debate about moving to triple pane windows for performance, but the minimum or maximum U value requirement, minimum performance requirement for Windows is a 0.30 U value. And one of the points options in the point side of this is iterating towards higher performing windows and moving towards triple pane. Another significant change for any category of compliance with the code as of July 1st is the maximum air leakage through the building envelope is going from 3 ACH50 to 2 ACH50, and also going to be calculated based on CFM per square foot of the building shell. So it's a different way of just using your CFM 50 blower door number and calculating the air leakage area. There's a different methodologies you can use to show that data. So that is the basis of reporting being put forth as of July 1st. The points table has been combined as well. In the 2020 RBs, you have 2 different points tables, one for base, one for stretch. They're now combined into a single table. The change here is that the points requirements for stretch code have increased versus what they are in the current code. So again, based on square footage, you have to earn points beyond what these prescriptive values were that I just shared with you. And that is based on the finished conditioned space of the building. And oftentimes, most of the time, are spaces. You have to look at which spaces include mechanical systems or not, and what's actually considered conditioned versus unconditioned. This is the points table from the 2020 RBES. So the way that you're able to earn points is through improvements and enhancements to the building envelope from the specified prescriptive values in the table, improved air leakage and better mechanical ventilation, more efficient or high efficiency heating and cooling equipment. Water use is accounted for in the points as well. Efficient water fixtures, plumbing fixtures, as well as things like drain water heat recovery and efficient water heating, renewables, and other measures. For the updated code, as I said, these points tables have expanded significantly. So there's a lot of emphasis on whole house electrification, meaning no fossil fuel heating equipment and relying on heat pumps. It is not a mandatory requirement to be using whole house heat pump systems, but it's certainly a highly valued points option looking prescriptively. Heat pump water heaters as well. The building envelope options also kind of move towards getting to those continuous insulation wall assemblies. So I realize this is not going to be easy to read, and also this is the edited version of the only content that's available right now of this points table. Once the final published document is available, it'll be much more cleaned up and easier to read. But we have points options available based on higher performance for wall assemblies and other building components, wall, roof, and floor assemblies. This is where you can earn points for better performing windows, up to 4 points for triple pane windows. Getting below 2 ACH 50 gets you points as well. The mechanical ventilation, improving upon the sensible recovery efficiency of the minimum performance requirements of mechanical ventilation, earns points, as well as doing commissioning of ventilation systems once they're installed as well. So you're basically verifying flows, that you're getting the appropriate flows for supply and exhaust throughout the house. This is where the bigger points options exist. This is the heating and cooling upgrade. So you have 3 different categories essentially of heat pump, whole house heat pump systems: air to air, ground source, and air to water. Ground source giving you 10 points, air to water giving you 5 points, and air to air giving you 5 points. Pellet systems, pellet wood systems, not cordwood systems, also are an option for 5 points. So expanding then in water use, there's more points options and categories for water conservation, more categories and more points options for renewables and other measures. And then we're also accounting for embodied carbon and emissions in material choice, specifically towards insulation materials, as a way to earn points in this update to the code. So I'm going to go into some of these in a little bit more detail in a moment, but this is the significant expansion in the prescriptive package option and the enhancements of points and what we're going to see for 2024.
Steve, a question came in.
Yep.
Carl says that they're a home energy auditor, and when they write up a scope of work for insulating an attic flat, do they prescribe R49 now?
If we're talking for weatherization in an existing home, then R49 has kind of been the understood minimum performance value for an open attic cavity. When it comes to existing homes, retrofits, the way that the code is written, if you have an open space or a cavity or a building component that's not restricted by cavity depth to attain R value, it's expected that you improve the R value of the insulation to what the code currently requires for new construction. But if you're working within a restricted cavity dimension of a wall or a roof slope, that the depth of the cavity limits the R value that can be achieved in that cavity, you're not required there to make those cavities bigger or deeper to meet current requirements in those different building components. So it has been understood that R49 has been the, kind of the minimum performance spec for improving an open attic for a while now.
Great, thanks. And Carl, if there's additional clarification needed, feel free to raise your hand too, and we can take you off mute.
Thank you.
No other questions at the moment, but we'll certainly stop you if anything else comes in.
Sounds good. So the other point to be aware of too, and this is why, I said it's good to dig through the full content and the published code and the ICC code, is that a lot of what Chapter 4 covers is installation and detailing requirements beyond just these prescriptive values for different building components. So there's a lot of content in Chapter 4 that gets around different avenues for vented and unvented ceiling assemblies, details around how to deal with soffits, doors, access points, requirements for vapor retarders and vapor retarder classes for different assemblies and different combinations of assemblies, exemptions for glazing, glass, so there's a lot of detail in Chapter 4 that needs to be paid attention to beyond what the minimum performance requirements are. And this is where also I think as builders and construction professionals, we need to be digging deeper into our material choices and material options and putting these assemblies together, because that is where the building durability piece comes into play, and understanding the interaction of materials and trying to make sure that we're building durable, moisture safe building assemblies, especially as we get into continuous insulation requirements that are coming into play. So there's more content in Chapter 4 here that gets into that, but then there's also, I think, a need to be doing your own research on your material options and your assembly details beyond what the code is calling for as well. So we do have a lot of content and training that we do around that as well. There's a session I did at the Better Buildings Conference beginning of the month that we'll have available, or is available on our website, that has more detail relating to that, and we'll continue to do more kind of deeper dives into that sort of content throughout the rest of the year and beyond.
Steve, we have a question before you go in this next section.
Sure, go for it.
For sloped attic ceiling insulation, will reductions in R values still be allowed for 100% coverage over the top plates?
Those exemptions do still exist, and it in the sloped ceilings category, it's for a percentage of total area and or a maximum square footage allowance when it comes to that lower R value exemption. For an open attic flat, there is still going to be the exemption of where right now, as I said, is R49 is the minimum R value for an open attic flat. And there's an exemption for R38 when a full height of R38 uncompressed is allowable over the exterior perimeter of the building envelope, so over your top plates of your exterior walls. So that's been an exemption that's currently in the 2020 RBES. It does carry into this updated version. So that's the big differential there. If it's in an open attic, you can do R38 through the whole attic flat if those conditions are met. If it's a slope ceiling, it's a percentage of the total area.
Okay, thank you.
Yep. Stretch code, I'll just kind of touch through this briefly because we've already kind of talked about it. But stretch code is a more stringent requirement, and it's higher standard of performance than what the base code requires. And it's allowable for local jurisdictions to adopt stretch code as a local requirement that's more stringent than the state requirement for RBES. But the only town in the state that has gone through that process and requires stretch code as a local requirement is South Burlington. One other factor to consider with stretch code is that if you are working in a project or on a development where an Act 250 permit is in play, then you're also in those scenarios required to meet the stretch code. So It's not just South Burlington. It's intended for, developments and other places where Act 250 is a part of the equation as well. So it's something to be aware of. And as I mentioned at the beginning, the compliance options are restricted to the prescriptive package option that we're talking about here, and or working with a HERS rater. You cannot use ResCheck. Yeah, this is the table and the points options that are in 2020 code. Again, this is what we have moving forward as of July 1st. The tables combined, so the same base requirements for prescriptive values of the building assemblies, and then just increased points values, which is the differentiation between base and stretch code when we're talking about prescriptive compliance. So now getting into the points options. So again, we've got minimum performance standards to be met there in the prescriptive table. And then, depending on the size of the house, you've got to earn X number of points to go beyond that. So let's look at some of these options that we have available. Air tightness, as I said, 2 ACH 50 is the maximum threshold. Oftentimes it's quite feasible to get below 2 ACH 50 without doing anything too heroic with the air barrier and the building envelope. Taping the seams of all of your sheathing tends to get you most of the way there to 2 ACH in the first place. And then it's the other details around the building envelope that, as long as you're paying attention to them, you can certainly drive those ACH numbers and that air leakage value well below 2 ACH 50. So depending on the outcome here, you can earn points based on that outcome. This is also, if you're planning to apply points here as your compliance pathway, you should probably be doing some midpoint construction or some blower door testing during the construction process to make sure that you're getting in the direction you intend to be getting for these targets, rather than just waiting until the end and having your final blower door test to be your, did we do it or not sort of approach.
Steve, we have a question about why ceiling insulation requirements are kind of going retroactive.
That's a whole nother conversation, but the long and the short of it, I think summary of it is that it's all based on modeling and a numbers game of trying to show a measurable improvement in energy, holistic total energy performance of the building, and that being valued against a metric of cost effectiveness. And that was how a lot of the debate and back and forth went in the code update process of what items offer the most benefit for the buck, and where can numbers be adjusted to get to the same net outcome. That's the best way I can summarize it here for now. There's a lot of stuff going on and a lot of conversations getting to that outcome, but the R values that are showing in the prescriptive package table there came from a lot of energy modeling that was done, weighing one improvement versus another. The net goal here with where policy-wise we're heading to meet the mandatory requirements the state has for the Global Warming Solutions Act is iterating towards net zero ready design and net zero construction. And when you're talking about that metric, which is still not a concrete metric that's been agreeable metric that's been landed to on that. And as you see these points valuations in the points table, where what the higher point values are iterating towards is you can achieve quote unquote overall building efficiency by putting more value into efficient mechanical systems than the building envelope. From where I stand, I think the building itself is the asset, and the mechanical equipment comes and goes with time. So I think there's certainly value in doing the most possible with the building envelope and building assemblies as can be done at time of construction, because those are the components of the building that are not going to be modified or improved later on down the road. But in the landscape of trying to balance out moving towards these mandatory requirements and finding some metric of cost effectiveness. That's how it landed with these, adjustments to the numbers that we now see.
Good, thank you.
So yes, ACH numbers, driving down ACH earns you points. There's a variety of ways of getting there. And like I said, we have a lot of content and trainings that get into this in more detail, but bottom line here is really it's about putting together assemblies to make them a whole and stitching together disparate components to make them unified in one way, shape, or another to create a good continuous barrier. And these sorts of details are critical for air leakage as a control layer, your air barrier control layer, but also the same attention to detail and air tightness really is important when we're talking about vapor control from the inside of the building as well. Being able to mitigate vapor drive into building assemblies requires attention and detail to air tightness on the inside as well. So being able to identify where your main, pathways for air leakage exist in the design of the building and being able to address those during construction is critical. Understanding where changes and transitions occur through assemblies and what materials and components need to be used to make those transitions airtight need to be known before you start putting the assemblies together. There's a variety of products from manufacturers on the market that are available to use to accomplish some of these outcomes. Peel and stick WRBs as a air barrier and WRB as one, spray applied air barriers, the zip products, you name it, but it doesn't have to be a specific product manufactured for that supposed outcome. It really is about, again, utilizing a variety of different materials, often in an assembly or a whole building to create an airtight assembly. So moving down this road is just a lot of figuring out what works best for the crew doing the work, for the conditions on site, the materials in play, and the budget for the job to get to the outcome. Continuous installation wall assemblies. Now, again, as I said, we're iterating towards this requirement without it being mandatory. That's kind of how the code landed. So again, as I said, it's not showing up in the table, and it'll show up somehow, I think, in the handbook probably is the way it's going to show up. But what the exception is going to be to allow for cavity-only installation still for above-grade walls, but it's looking like it's going to be a significant points penalty to do that. So looking at what the best options are to do continuous installation wall assemblies is where we're iterating towards in our content and training and support. And the information that's going to be in the code handbook is going to have a lot of detail to dive into about how to create durable, moisture safe assemblies here. And the points options in the code are iterating towards higher points values for higher overall R value, higher performing wall assemblies. These are some of the details I'm talking about that are in the current code handbook and that are in the process of being updated for the new version to come out. But essentially, there's a variety of different ways to get to continuous insulation above grade wall assemblies. And what really is important in detailing these is the consideration of the materials going into, man, this thing's really jumping along. Consideration of the materials that are going into each of these assemblies. They have to behave and play well together. And if you're using any sort of vapor permeable materials in the assemblies, which we often do in the cavity, rock wool, fiberglass, mineral wool, cellulose, wood fiber, those are all vapor permeable insulation materials. And when we detail our vapor retarders on the inside of the building envelope very well to make them airtight, we mitigate the amount and the possibility of vapor transport into these wall and building assemblies, but we can't stop it. It's some vapor transport will occur. And when that does occur, it needs a pathway for drying. And then the ability for that assembly to dry is really incumbent on the vapor permeability of the materials in the entire assembly. And that goes for the sheathing layer, the WRB, the vapor barrier or the vapor retarder, pathways for drying based on a rain screen or ventilation pathway on one side of the wall or the other. So these are all considerations that need to be taken into account when you're detailing and defining what type of continuous insulation wall assembly you're going to build, what ratios you're going to use of continuous insulation versus cavity insulation, and what the characteristics are of the different materials and the layers of that assembly to create not only an efficient assembly, but a durable assembly for the long term. And mitigating risky assemblies as much as possible. And by way of saying a risky assembly, these are assemblies that have a minimum potential for drying when moisture is introduced into those cavities. These are cavities that if you cannot mitigate the overall moisture load in that assembly seasonally so that as it does load with moisture during the heating season, it has the ability to dry out and come to a balancing point during the warmer months of the year. If that mechanism is not in place, then we stand to find damage to these assemblies for the long term. So, common approaches, double walls, depending on the framing depth and the separation between the two, you can achieve just about any R value you want through a double stud wall assembly. Exterior rigid, where you're framing a standard wall, sheathing it, and then putting continuous insulation board over the exterior of that sheathing. It's a pretty common and approachable way to get there, and there's a variety of different material options for putting these assemblies together. So this is a common approach as well. Nail-based panels are becoming more and more commonly used, where the switch up on this is the sheathing layer is outboard of the continuous insulation. There's some benefits and drawbacks for using this approach to get to that outcome. But again, these can be durable assemblies as well, as long as you're accounting for that drying potential necessary in these types of situations when using these materials. SIPS panels, same sort of thing with the double stud wall. The specification of the insulation type used between the two sides of the panel and the thickness of the panel dictate the R value of the overall assembly. Details really matter when it comes to SIPS assemblies as well too. They need to be durably airtight, because a lot of damage can occur if there's a lot of air being driven between the panels. It's a vector for moisture transport as well there too, but SIPS is still an option. Arctic TGI truss wall assemblies, not a common approach, but definitely a way of getting there, where you're framing the standard wall assembly, and then outboard of that wall assembly, you're putting your primary, your thermal barrier essentially, and that would be a TGI or some sort of on-site built truss that is basically just an open cavity to be filled with insulation over top of an airtight air barrier sheathed all behind it. So there's a variety of different ways to get there. There's not any mandatory requirement to do one versus the other. Again, it comes down to material choice, to what makes sense, what's cost effective, and what's in the long term durable when putting these assemblies together. Windows, a bunch of options here for driving down the U value and earning points. Double pane window at 0.30 is easily attainable now. The 2020 code, your options are 0.28 or 0.30 as your minimum performance requirement for Windows. Getting below 0.30 in a double pane often and typically requires a low E coating on the interior face of the double pane window, on the interior face of glass, which raises the condensation potential of the window as a result, because you're reflecting heat energy back into the room. So there's been a lot of good and bad going with that approach of getting to lower U value and weighing the risks to get there in a double pane window. Triple pane windows, by creating a secondary pocket of air and isolation from the inside of air conditions and temperature conditions to the outside conditions, definitely and noticeably increases the comfort factor of being near these windows and still feeling warm, essentially. You have more more comfort impact than you could argue than energy efficiency or performance impact with these windows. And then also that secondary isolation of air between inside and outside really drives down condensation risk on these windows as well. You have very little potential for condensation to form on the interior pane of a triple pane window, as long as you have an adequately running mechanical ventilation system in the house. So not mandatory, but certainly a points option. There's more options for product on the market now, and some more cost competitiveness between triple pane and double pane windows now than there have been in the past. Embodied carbon emissions and global warming potential impact of insulation materials is accounted for as a points category now for the updated code. This is driven by some significant differences in these sorts of impacts by material choice. There's a drastic difference in energy intensity to manufacture, and then also potential global warming potential between, as an example, cellulose insulation and mineral wool insulation. Very drastic difference between those impacts from one insulation type to the other. There used to be just as significant of an impact difference between closed cell foam and higher density foam insulations because of the blowing agents that were used in the reaction of the two components in the manufacturing of those materials. The state of Vermont passed regulations a couple years ago now that ban the use of hydrofluorocarbons as blowing agents in the manufacture of foam insulation materials. So as a result, those impacts have been significantly reduced in both spray foam and rigid board insulation foam stock because of that requirement. And that's why you've seen your extruded polystyrene is no longer pink or blue, it's now gray. That's because the manufacturers have had to change their formulations to meet these requirements as well. But there's a tool, it's called the BEAM tool, that you can use to calculate embodied carbon in materials, and that's available online if you want to consider using that and earn some points in this direction as well. Mechanical ventilation, as I said earlier, up until now, you could still use exhaust-only ventilation and be compliant with RBES. So that meaning you can have a bath fan or bath fans in the home on a controlled timer that would allow them to run at a set interval throughout the day to exhaust air from the building and hopefully create air exchange as a result. Our building envelopes and the way that we're putting the building shell together has outstripped the capacity and ability for exhaust only ventilation systems to really be effective. And thankfully, in my opinion, the code has caught up to that reality, and now as of July 1st, balanced heat recovery ventilation is mandatory. So there is a minimum performance requirement of a 75% SRE, sensible recovery efficiency, for either an HRV or ERV as your base standard of what to specify and needs to be installed. But you can earn a point by putting in a higher efficiency heat recovery ventilation piece of equipment. And then you can earn 4 points if you're actually testing and commissioning that ventilation system. Why this is important, I'll just get into this in a little bit more detail. Defining that we need to have balanced heat recovery ventilation is mandatory moving forward for the 2023 RBES. When we're doing this, you're actually designing the piece of equipment to do the ventilation for the building in a similar methodology as you would be for designing and sizing a heating or cooling system for the house. You're taking the specific details of the size of the building, the location of the building, what climate zone it's in, number of occupants, air leakage through the building shell, and those data points go into calculating the ventilation requirements, how many CFM of air exchange is necessary to maintain good indoor air quality, and in our climate really keep relative humidity in check with that system. And the ASHRAE standard is kind of the uniform industry standard to be used to do those calculations and come to that requirement. There's a tool online called the RedCalc tool, which you can easily access and use to enter in building data and then get a result for what the flow requirements are. The Passive House ventilation standard is also an alternative allowable for that. But what we're doing here is with a balanced ventilation system is not just relying and hoping that the building envelope's going to leak to get fresh air exchange. We're actually creating a balanced system where you're pulling in fresh air from the outside and exhausting stale, humid air and other pollutants from inside the house to an equivalent rate. So there's a balance in the system here. You're not depressurizing the building. You're distributing air throughout the entire building. But a key component to a successful outcome in this is that the HRV or ERV that you're choosing to use has the capacity to move X number of CFM and recover X percent of heat energy from the exhaust stream of air to be put into the incoming stream of air. And another detail to be paying attention to here for our climate is that it has a good defrost strategy. There is definitely differences in equipment out there on the market. And what you want to definitely be putting in our climate is a ERV or an HRV that can still operate when it's 10 degrees outside. And it will not be shutting off and or recirculating because the cold air coming in is freezing up the core. So that's when we really need the ventilation the most, is during the cold winter months. So knowing what your specs are and what your options are for equipment to have equipment that will perform under those conditions is critical. But again, that's just the performance potential of the ERV or HRV unit itself. It's a box with a fan and a blower motor in it, a heat recovery core, and 4 ducts coming off it. To create a system, you have to connect ductwork to it, distributing that air throughout the house. And that duct system and that duct design is just as important as what that fan and that unit itself can do. So you really need to be accounting for mechanical ventilation as a system and as a design into the building at design stage. So you have to know a location of where the unit's going to be that's accessible and can be maintained and serviced. And you need to know where your main supply lines and your ducts are going to go so that you're not being blocked by girders or trusses or beams that prevent appropriate airflow. And then also this is where that points option of gaining 4 points by testing and commissioning is really, I think, a great way to earn some points, and also just necessary performance commissioning that needs to happen for these systems anyway. You want to make sure that you're actually getting the flows into the rooms that the system was designed and intended to deliver. And then you also have to have components in the duct design that will allow for adjusting those flows as you start to commission the system, because you don't want to have the intended 20 CFM being pulled from a bathroom and then realize that the way that the system was installed is only allowing 4 or 5 CFM to be pulled from that bathroom. You want to make sure that you have the ability to adjust flows and you've got good duct design so you get the maximum potential out of the equipment once it's installed. So something to dig into a little bit more and consider for points. Heating and cooling, as I was talking about, is how do we come to these values for our values, et cetera. There's this tipping point or balancing point between, trying to achieve efficiency with the asset of the building envelope versus putting in more efficient mechanical equipment and or renewables. The code is not banning the use of fossil fuel equipment at this point. You can still 100% be using propane, natural gas, oil, heating equipment, moving as of July 1st and moving forward. The higher efficiency of the equipment, you can earn a single point if you're using Energy Star equipment, which is pretty straightforward and standard and would be kind of status quo anyway. But again, as I showed earlier and mentioned earlier, we're iterating towards trying to do whole house heat pump systems. And so you can earn significant points by using that type of equipment and going down that road for your heating and cooling side of the equation for the building. And just to close us out here on that direction, there's a variety of different heat pump options as far as delivery goes. A heat pump's a heat pump. It's a refrigerant system that moves heat energy from one place to another, and then how that heat energy is delivered into the building and or removed, if we're talking about air conditioning. You have different mediums that are available to use to move that energy. So air to air, where you're essentially using the refrigerant exchange to blow air across the hot refrigerant coil, and a forced air, and that can be either a ductless wall-mounted unit and or a forced air whole house distributed system with ductwork. Water or ground to air, same sort of thing. You're doing an exchange and using air as your distribution medium, and then air to water and ground to water. So a heat transfer occurring, heat exchange occurring, where that heat energy is then put into a hydronic distribution system. So these are all distribution option types that are allowable and efficiently achievable through using heat pumps, either air to air systems, water to air, or ground source. And no matter what type of equipment that is being used in the house, from a heating standpoint, we should really be thinking about the distribution system that's attached to that equipment, no matter what it is, as a permanent asset to the building, and should be designed to be resilient for what's currently available for equipment and or anything that may come down the line. Heat pumps are low ambient temperature delivery equipment. They deliver heat efficiently, but they don't deliver high temperature heat, which is what we've become accustomed to with fossil fuel equipment. So as long as you're designing a distribution system that's based around low temperature delivery, whether it's water or air, you're going to have the most flexibility for using heat pump equipment, and you're also going to get the highest efficiency possible out of any fossil fuel equipment as well. If you're using a condensing gas or propane or natural gas boiler, the lower the water temperature delivery moving into the house and the higher the delta is between the energy going into the house and then what's coming back into the furnace or boiler, the more efficient that furnace or boiler is going to run. So it's the same methodology comes into play, no matter which one we're talking about, heat pumps or fossil fuel equipment. So really considering the distribution system as a fixed asset for the building, no matter what heating system you put in at the time the house is built, at some point down the road, 20, 30 years, hopefully at least that long, that piece of equipment is going to need to be replaced. But you're not going to be replacing your distribution system at that time as well. So just future proofing and consideration in the overall system design. And finally here, just water heating are some points options. Higher efficiency heat pump water heaters earn you some points. Using efficient plumbing fixtures that are low flow earn you points. Drain water heat recovery, recirculation, etc. And renewables, where there are some requirements for solar ready design for multifamily that are mandatory. For base code, you can earn points with having solar ready design, and then if you're actually installing PV at the time of construction, you can earn some points there as well. So we're at an hour, so that covers it for content here. I'm happy to stay on for a bit if anyone has some further questions, and appreciate you spending the time with us this morning.
Thanks so much, Steve. If folks have any questions, please put them in the chat or raise your hand. We want this to be a valuable webinar for you. So if there's anything we went over too quickly or you would like a little bit more clarification on, now's a great time.
Yeah, that was a lot to kind of jam through in an hour, so happy to talk.
And our next training in this series will be mechanical ventilation requirements next month. So if you are going to join us for that webinar, we look forward to seeing you then too. And please keep an eye out for in-person trainings that we're offering around the state as well. Those are also approved for AIA credit
traveling roadshow. I'll be in Marlboro on Tuesday.
Yeah. Yeah, Montpelier, Marlboro, Rutland. Those are also great chance to see people in person and ask questions. Yes, we record these trainings and post them on our ECAC webpage. The links for those. It does take our web team about 2 weeks to get these posted after the session ends. So just check back. These websites, training website and ECAC support pages are updated frequently right now. All right, I'm not seeing anything else. Thanks so much for joining us today. Hope you have a great weekend, and we'll see you again soon. Thanks, Steve.
Yep. Thanks, everybody. Take care.